Title of these notes are Solving Quadratics Summary. And by quadratics we mean our standard form ax squared plus bx plus c is equal to 0. So for the rest of these notes, when I refer to A, B, or C, those are the A, B, and C. All right, I'm going to divide my paper now into 4 parts. I'm going to try to get all these on one sheet of paper so that you can, in theory, see all of our review here on one page. We haven't talked about this in this unit, but we have talked about it recently. I want to begin by solve by graphing. Most of these methods we'll talk about, the first step will be to set equation equal to 0. And then after we set the equation equal to 0, we will graph it. After we graph, we will find the X-Intercepts. Recall we have the purple board at the up near the clock. We have these 4 almost synonyms: X-Intercept, X-Intercept, 0, root, and solution. Poor planning on that, forgive me. Those 4 words are almost synonyms: solution, root, X-intercept, and 0. All right. So when we graph our parabola, when I do my graphing, we know it's going to be this U-shaped curve. And we are seeking these X-intercepts. Oftentimes there's going to be 2 of them. If the vertex is on the x-axis, there would be one solution, and if there are no X-intercepts, there would be no real solutions. We would have our imaginary solutions. And then the last step on all of these will be to check the solutions. Next, factoring. Just like with graphing, we'll first set the equation equal to 0. Then we will factor. Then we will set each factor equal to 0. The zero product property allows us to do that. Write out zero product property if that ZPP is not meaningful to you. And then we will solve and check. Put your pencils down when you're ready. You got a color preference? Blue, I heard. All right. These top two methods can't be used all the time. Graphing, if there are no X-intercepts, obviously we won't be able to find the imaginary solutions. Factoring, only certain polynomials we can factor over the integers. The next two methods we can use all the time. Quadratic formula. I'm not going to rewrite the quadratic formula notes. You can see it on the board up there. You should have it memorized by now. Here come our steps. Again, we will begin by setting the equation equal to 0. Then we will identify A, B, and C from standard form. Next, we will evaluate. See if I can spell evaluate properly. Evaluate and interpret the discriminant. It's two N's. Discriminant. Recall that the discriminant is the underneath part, the radicand of the quadratic formula. It's the b squared minus 4ac portion. When we interpret the discriminants, you can look back at your whole notes from here. We compare it to 0. When it's greater than 0, 2 solutions equal to 0. 1 solution less than 0, no real solutions where we have our I solutions. If you want to add that in here, just turn back to your notes from a few pages before you can find that. Also, if the discriminant is a perfect square, we can factor. Final step. Substitute sub into the quadratic formula. Solve and check. Yeah, I've got room there. I'm gonna cram the quadratic formula in there. You can do it or not do it if you don't have space. Let's see. Go with something small here. Orange. The quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. Color? Green it is. Light green, dark green. I think you said light green. Lastly, we have completing the square. It differs in that we won't be setting the equation equal to 0. Our first step here is to divide by a. Recalling if a is 1, that's trivial. Step 2, we're going to gather the variable portions on the left and the constants on the right. Of the equal sign. Left side of the equal sign, right side of the equal sign. Next step, we're going to add the box number. Where the box number is 1/2 of b squared. Recall we can take half of any fraction by doubling the denominator. Half of any number in that, actually. If you consider the denominator of a whole number is 1. We're going to write the left-hand side as 1 binomial squared. One binomial squared. Last, we will solve, and that solving will involve taking a square root and check. That concludes your required notes.